Since 1974, Multi-Shifter Incorporated in Charlotte, North Carolina, has manufactured the finest battery handling equipment in the industry. We've installed over 1,000 systems worldwide. In equipment, design is everything, and our designs have kept us ahead of the competition for over 20 years. To see why Multi-Shifter is the industry leader, let's compare a competitive battery handling vehicle with a multi-shifter vehicle. The competition, BHS, Sackett, and MTC, all use the same basic machine with the same basic functions. A rotator arm is used to move the vacuum arm from one battery compartment to another. This allows the vacuum cup to access batteries in either battery compartment. The vacuum arm is mounted on a large screw jack, allowing it to traverse within the battery compartment. As we will explain in detail, the design and dimensions of the rotator arm forces the competition to use powered rollers in each of the battery compartments. The multi-shifter vehicle uses a bridge that travels over the batteries. The magnet is mounted to a yoke, which is mounted to the bridge. This design allows the magnet to travel in a circle around the battery compartments. The multi-shifter vehicle uses a free-flowing roller bed. Powered rollers are not needed because the magnet can pull the battery from one side, then travel around the battery and push it from the opposite side. The competition's rotator arm literally can't get out of its own way. Let's view a competitive battery change and then a multi-shifter change. The difference will be obvious. To begin the change, the competitive vehicle moves the rotator arm into the battery compartment. Then the vacuum arm traverses to pull the battery out of the stand. Eventually, the battery must travel to the opposite side of the battery compartment, but the vacuum rotator arm is in the way. So the first rotator arm must be moved out of the way. However, there is still a problem. The present position of the battery in the compartment will not allow the rotator arm to get behind it and push it into the truck. To move the battery into the proper position, powered rollers are essential for the competition. Next, the rotator arm is moved into the battery compartment. The vacuum arm then attaches to the battery in the lift truck to pull it onto the compartment. Batteries weighing more than 3,000 pounds may require several attempts to attach the battery. Once the vacuum cup is attached, the battery is then pulled onto the compartment. Once again, the rotator arm is in the way of a productive battery change, so the rotator arm must be moved and powered rollers must be used to move the batteries into the proper position. The vehicle then travels forward to align the battery compartment with the truck compartment. Since the rotator arm cannot get behind the battery, the powered rollers must push the battery partially onto the truck compartment. However, the powered rollers cannot finish the job. The rotator arm must be lowered into the compartment and finish pushing the battery onto the truck. Sometimes the vacuum cup has a hard time releasing from the battery and must be peeled off the battery by moving the rotator arm. The rotator arm is then moved back into the compartment and the vehicle travels to the battery stands. The rotator arm is positioned, and the powered rollers move the battery into position. So the rotator arm can push the battery back into the stand. The rotator arm is then brought back into the vehicle compartment, and the change sequence is complete. Now that we've seen the competition's battery change, let's examine the multi-shifter change. The bridge traverses the magnet to the battery, and once attached, the battery is pulled out of the compartment. A slight height adjustment is made, and the battery is pulled completely onto the compartment. The magnet is then disconnected and moved into position to extract the lift truck battery. The bridge traverses the magnet to the truck compartment, and the battery is pulled into the compartment. A slight height adjustment is made, and the battery is fully and properly positioned onto the compartment. The magnet is disconnected, then positioned to push the fresh battery into the lift truck. The multi-shifter vehicle then aligns with the truck battery compartment. A slight height adjustment is made, and the fresh battery is pushed into the lift truck. The vehicle then travels to align with the battery stands. The magnet is positioned behind the battery, and the battery is then pushed into the stands, completing the change. As you've just seen, the multi-shifter change is fast, safe, and productive.